Each year, millions of tons of rice husks are burned worldwide, causing severe air pollution and directly affecting human health. Meanwhile, in China, husks are treated by safe methods, limiting environmental impact, while creating products with economic value and widely applied. So what is this product that both protects the environment and brings such great economic value? This is the Yangtze River Basin and southern China, where over 60% of the country's rice area is produced. With an average yield of 7 to 7.5 tons per hectare, this region not only provides food, but creates millions of tons of rice husks, golden raw material for the modern biochar industry. The process starts with the early rice season from March to April and the mid-season rice from August to September. Early rice takes 90 to 100 days to grow, while mid-season rice needs 110 to 130 days from planting to harvest. Each rice grain brings not only nutritional value, but its husk will become an excellent soil improvement material. Harvesting is the most important time. Modern combine harvesters move across the fields, cutting rice, separating grains, and blowing away husks in a fully automated process. Each season, 1 hectare of rice fields can create about 1.4 to 1.5 tons of husks, enough to produce over 600 pounds of high-quality biochar. But the journey of rice husks does not stop here. From rice fields, they are transported to modern milling factories, where a miraculous transformation is about to take place. Let's explore how these useless husks become the most valuable material in sustainable agriculture. Welcome to the modern biochar production plant. The first stage is collection and sorting of husks. After milling paddy rice, husks are separated and gathered at the receiving area. An automated conveyor system transports husks through vibrating screens to remove impurities like soil, rocks, and broken rice grains. Only clean, uniform husks are transferred to the next stage. The second stage is extremely important: drying and stabilizing moisture. Fresh husks have about 12 to 15% moisture, but for effective pyrolysis, moisture must be reduced to 8 to 10%. Husks are put into a rotary dryer at 150 to 180 degrees Fahrenheit for 30 to 45 minutes. An automated sensor system monitors and adjusts temperature to ensure uniform moisture, avoiding burning raw materials. This is the perfect preparation step for the magical transformation process. And here is the heart of the entire process: anaerobic pyrolysis. Dried husks are loaded into a giant pyrolysis reactor where they are heated at 800 to 1000 degrees Fahrenheit in an oxygen-deficient environment. No direct fire, just heat. This process lasts 4 to 6 hours, transforming the molecular structure of the husks. Cellulose and hemicellulose decompose, releasing syngas, while carbon is retained in solid form. The conversion rate is impressive. From 1 ton of husks creates about 400 to 450 pounds of biochar. After pyrolysis is complete, red-hot biochar at nearly 900 degrees Fahrenheit needs to be cooled immediately. An indirect cooling system uses circulating water in closed jackets, helping lower temperature from 900 degrees Fahrenheit down to 150 degrees Fahrenheit within 2 to 3 hours. Without letting air contact directly, this prevents biochar from burning. At the same time, excess heat is recovered to produce steam for other stages, optimizing energy. Raw biochar after cooling still does not meet standards. The next stage is grinding and classification. Hammer mills rotating at speeds of 1,500 to 2,000 revolutions per minute break large coal lumps into small particles. Then a 3-deck vibrating screen system classifies by size. Fine particles under 2 millimeters for family agriculture, medium granules 2 to 5 millimeters for large-scale soil improvement, and coarse granules 5 to 10 millimeters for industrial water filtration. Each type has its own application and different market value. To increase absorption capacity and commercial value, a part of biochar goes through the activation stage. Chemical activation methods use 10 to 15% phosphoric acid solution or potassium hydroxide, soaking charcoal for 2 to 4 hours at 175 to 185 degrees Fahrenheit. Then, charcoal is calcined again at 1,200 to 1,400 degrees Fahrenheit for 1 to 2 hours to create a superporous structure. Surface area increases 5 to 10 times, from 100 to 150 square meters per gram up to 500 to 1,500 square meters per gram. This helps biochar absorb pollutants, retain water and nutrients many times more effectively. Quality control is an indispensable step. Each batch of biochar is sampled randomly and sent to a modern lab. Technicians test carbon content, must reach minimum 60 to 70%, pH 7 to 9 for agricultural applications, surface area, and ash content under 15%. TGA thermogravimetric analyzers and FTIR infrared spectrometers determine molecular structure. Only batches meeting international standards are allowed to be packaged and shipped. The final stage in the factory, automated packaging. Standard biochar is put into an automated bagging system by weight. Electronic scales accurately measure each 20-pound bag for individual farmers, 50 pounds for cooperatives, and 2,000 pounds, 1 ton, for large agricultural companies. Industrial robots stack bags on wooden pallets, wrap PE film to protect against moisture. Then autonomous forklifts move them to the finished goods warehouse. Each day, this factory packages over 100 tons of high-quality biochar ready to reach users. Before leaving the factory, let's look back at the whole process comprehensively. From useless husks to valuable biochar, every stage is optimized by technology and science. Automated management systems monitor every parameter in real time, from temperature, pressure, to conveyor speed. Energy from syngas is reused to dry husks and generate electricity for the plant, reducing energy costs by 70%. This is a perfect circular economy model. No waste, only value. The journey of biochar does not stop at the factory gate. Container trucks carrying thousands of biochar bags leave the industrial park, heading to distribution centers across China and the world. Modern logistics systems use QR codes on each bag to track the journey from factory to warehouse, from dealer stores to farmers' hands. Blockchain technology ensures transparency and origin verification. At agricultural distribution centers, biochar is transferred to different channels. Retail stores serve small farmers with convenient 20 to 50 pound bags. Cooperative companies buy large quantities by pallet. E-commerce platforms like Taobao, Tmall bring products to millions of households in just 24 to 48 hours. Selling prices range from $0.50 to $1.50 per pound, depending on type and order size. Affordable, yet highly effective. Finally, biochar reaches users, farmers, gardeners, and environmental scientists. Mr. Li, a vegetable farmer in Jiangsu province, mixed 5 to 10% biochar into the soil before planting tomatoes. The result? Yield increased by 25%, fertilizer use decreased by 30%, and soil retained moisture 40% better. Or Ms. Wang, a soil remediation expert, used biochar to absorb heavy metals, cleaning up dozens of hectares of contaminated soil in just 2 years. Numbers don't lie. The biochar industry from rice husks in China currently has a value of billions of US dollars annually and is growing 15 to 20% per year. Last year alone, China produced over 2 million tons of biochar, of which 40% was from rice husks. This not only solves the problem of agricultural waste, but also creates tens of thousands of jobs from farmers, factory workers, to engineers, scientists. This is truly a circular economy model, turning waste into resources, turning challenges into opportunities.